In this video, we're going to ump the ante a little bit with regards to adding and subtracting rational expressions. In this case, we have unlike denominators. So what we have to do when we have unlike denominators is, in fact, we have to factor our denominators. So that's the first step. So when we look at our denominator, we want our denominators to be the same. And the only way we can do that is by factoring. So the first thing we're going to do is we're going to factor each denominator. So when I'm looking at this polynomial here, keep my numerator the same. When I go through all the steps of factoring that denominator, I'm going to get x plus 5, x minus 2. And if you don't remember how to factor, I'm not going to spend time doing it on this video. You need to go back and review, but factoring is huge. Now again, we have to be careful because we have this negative going on here, so just keep that in mind. I decided I was going to show you one that had a lot going on. So we're going to keep that negative, and we're going to keep them separate fractions. We have to keep them separate fractions because we do not have the same denominator, so we cannot combine them. When I factor this, I get 2, and then I get x plus 5. So let's go ahead and put our numerator in parentheses and our denominator, and our other numerator in parentheses. Make sure everything's in parentheses. So let's write that as a step. So we're going to put each numerator in parentheses. Okay? So parentheses. Okay, so that's going to help us not to get confused with what we're doing. So now what we're going to do, the third step, which is very important, is we're going to look for missing factors. Okay, so when I look here, I see I have x plus 5, x minus 2. When I look here, I see I only have 2 and x plus 5. So I want the denominators to look exactly the same. Word of caution, you probably could do this. You could see that these two, you may want to divide those out. The problem is that when you do that, you notice that you still have to deal with like factors, okay? You'll end up actually multiplying it back in. But let's go ahead and do that anyways. That wasn't my first thought, but let's go ahead and do that anyway. So we notice that these divide out to 1, okay? So this divides out to 1. I'm kind of changing my plan on how I wanted to do this. So now I have x minus 2 in the denominator, and here I have x minus 2 in the numerator, and then I have 2x plus 5. Okay, so it's very tempting to want to divide those out, but I cannot because they're in two separate fractions. Okay, so now I'm going to look for missing factors. So this one here looks like it needs a 2 and an x plus 5. It wants to have these two factors here. This 2 and this 2 are not the same. So that means here I need to multiply this denominator by 2 and x plus 5. What I do on the bottom, I also have to do on the top. Okay? So this intentionally is a number 1. Do not divide that back out, or you've just done everything that you've attempted to do. So this denominator has 2, it has x plus 5, but it's missing x minus 2. So it needs to have an x minus 2 in the denominator, and whatever I put in the denominator, I have to put in the numerator. So again, notice that x minus 2 divided by x minus 2 is 1. So I'm not changing the value of either fraction, because every time I multiply by 1, it stays the same. Okay, so now my denominators, do they look the same? 2, x plus 5, x minus 2. 2, x plus 5, x minus 2. They do. They look exactly the same, which means that I have a common denominator, which means I can share. I write my big fraction bar. I have 2, x plus 5, x minus 2. That's my common denominator. So the fourth step is get common denominator. And remember, common means that they share. Means the same as they share. Okay, so now I have to be very careful with my numerator because I have this minus sign here. So I'm going to write in my minus sign. I'm actually going to highlight that. And remember that that gets distributed to everything after it. So I'm going to put that big bracket there. This here is just 2 times x plus 5 times 1. So I know 2 times 1 is 2. So I basically simply have to distribute this 2 into the x and into the 5. So I get 2x plus 10. I no longer need the parentheses. I'm going to go ahead and copy this down here. So I'm just copying that down here. So I have to multiply this out. And notice that they're inside that bracket. So this here I have to multiply. So when I multiply that out, I'm going to get x squared minus 4x plus 4. Okay? So I have to be very careful about how I transfer that back in. So what do I have? I have 2x plus 10, and then I have that minus. I'm going to put that big bracket, and then I don't multiply out the denominator. I'm going to keep the denominator always in factored form. So now I'm going to put that inside my bracket. X squared minus 4x plus 4. Notice I just copied that in. So now I have to remember I'm going to distribute that negative in. So then that's going to change my numerator to be 2x plus 10 minus x squared plus 4x minus 4. And again, I'm going to leave my denominator factored. And now what I'm going to do is I'm going to combine like terms in the numerator. So I don't see any other x squared terms. So this first term is going to be negative x squared. Then what do I have? I have a 2x and a 4x. So that's going to give me a 6x. And then I have a 10 and a minus 4. So that's going to give me a 6. And then my denominator. So typically we don't multiply those out. We keep it as is. My numerator is in fact prime. So there's no way I can factor it to see if I have like terms on the top and the bottom to simplify. So I'm going to leave it like that. But then if you remember, I have to look for restrictions on x, okay? So what are my restrictions on x? So I'm going to do two things. I'm going to look at my original, which was x plus 5, x minus 2. These two are the same, so I only need to do it once. If I look back where I got a common denominator, I see it as the same. So my denominator, x plus 5, cannot have a value of x that would make it 0, and my factor x minus 2 cannot have a value of x that makes it 0, which means I have the restrictions where x cannot be negative 5 and x cannot be 2. So here, as part of my simplification, I would say x cannot be negative 5 and x cannot be 2. So that is my full answer.